Hi guys, so in this video I wanted to talk about exponential functions. Exponential functions are a special type of function that have a certain format, but I'm not going to tell you the format yet. First, in order to sort of understand how important exponential functions can be when being applied, I'm just going to give you guys a question. So, let's say we had some block, okay, and it consisted of a single type of element. I don't know what type of element it is, but it's a single element, okay? And there are a certain amount of atoms in here. Let's say that there are 100 atoms. Okay? I'm not going to fill the box completely, but 100 atoms, okay? And every year, half of them decay. So every year, half of them are going to be gone. We'll just consider them gone. Okay? And we want to know how many atoms after 10 years. Okay? Now, there's a certain format that we can actually use to find out how many atoms we have after 10 years. And you might have already figured that out, but if you haven't, we can write it as the number of atoms that you have at the end, so what we're trying to find, is going to equal 100, so the number of atoms you had at the beginning, times 1/2, so that's our decay rate, to the power of 10. Okay, so let's think about why this works. 100 is our initial amount of atoms, right? So we have 100 atoms at first, right? Now when we multiply this by 1/2 once, we're going to find out how many atoms there are after 1 year, right? Because every year, 1/2 of them are gone. So only 1/2 of them will remain after 1 year. Now when we put 1/2 to the 10th power, we're halving it 10 times. And that's what you need to do if you're trying to find out how many atoms are going to be left after 10 years. Because half of them are going to decay every single year, and it's going on for 10 years. So we have to multiply it by 1/2 10 times. So that would be how we would solve it. I'm not actually going to solve it, but you're welcome to if you want to. But how does this relate to exponential functions? Well, exponential functions share the same sort of form that we used in order to solve this problem. So I'll write it for you. It's f of x equals a times b to the x, where a and b are both constants. So in this case, a was 100 and b was 1/2. And x would be how long it's been going on for. So if we wanted to find out how many atoms there would be after 100 years, we could use a function like this. So we would plug in 100, we would plug in 1/2, and then we would plug in 100 again, because it's 100 years. But a and b are both going to be constants in this sort of function. So just to recap, we had this example, right? And we came up with an equation for it, and we found out that this sort of equation, this sort of format for the equation, can be generalized, and it's actually categorized as an exponential function. So all things in the form of a times b to the x is an exponential function, where a is usually your initial amount, b is how much you're multiplying that initial amount by, and x is how many times you have to multiply by b, right? So let's try another example just to show sort of how general or how versatile this function is. Okay, this type of function is. So exponential functions. So let's say that we have some amount of apples, okay? Those might not look like apples, but they're apples. Let's say we have 3 at the beginning, okay? So 3 apples. Now, every single year, these apples double somehow, okay? So times 2 every year, or every month, let's say. Okay? And we want to know how many apples after 3 months. Okay? So how could we use this function, this sort of format, to find out how many apples we'll have after 3 months? Well, we know that A is going to be our initial amount, so it's going to be 3, right? And we're going to multiply it by how much we're multiplying it by every unit of time. And in this case, it's a month. Our unit of time is a month. So we're going to multiply it by 2 to the x, okay? So that's going to be our function. Now what do we need to do to find out how many there are going to be after 3 months, right? Well, we just have to plug in 3 into x, right? So we would say f of 3, right? Because x is going to be 3. If this is confusing for you, this function sort of thing, you might want to look at some of my past videos, or you can look up something online. I suggest some other learning websites like Khan Academy, because those can be helpful. But back to it. F of 3 would be 3 times 2 to the 3 power, right? So what is 3 times 2 to the 3 power? Well, it's 3 times 8, right? What's 3 times 8? Well, it's 24. And our answer is 24 apples. There will be 24 apples after 3 months, okay? Okay, now what if we wanted to know, instead of 3 months, how about 3 years? Okay? Now this is a little bit more tricky because instead of months, now we have years. And we know that it's times 2 every month, not times 2 every year. So we cannot directly plug in 3 into x, right? Instead, we have to convert these years to months, right? So what is 3 years in months? Well, we know that there are 12 months in 1 year, right? So 3 years, right, times 12, right? Because there are 12 months every year, and there are 3 years. That's going to be 36 months, okay? Now, if we plugged it in, we would have to say f of 36, right? Because we had to convert it to months, right? So it's very important that you note that whatever your unit of time is, so in this case it's months, you'll have to convert to that. So f of 36 equals 3 times 2 to the 36. And I'm not going to solve that, but you're welcome to. Yeah, so f of 36 equals 3, which is our initial amount, right? Times 2, which is how much we're doubling, which is how much we're multiplying by our initial amount every month, to the power of 36, which is how many months we're actually multiplying by 2. So that's exponential functions. And I just want to go over one more thing before we finish the video. So exponential functions can be both growth and decay functions, okay? So growth or decay. And growth and decay They're basically categorized as growth would mean as x increases, f of x increases, okay? So if you think of it as like f of x equals a times b to the x, right? If x increases, then so will f of x, okay? But in a decay function, if x increases, then f of x will decrease, okay? Now, when does a growth situation sort of happen? Well, if b is greater than 1, then growth will happen, and I'll explain that why in a second. And if b is less than 1, then decay will happen. Now, why is that? Well, if b is greater than 1, you can imagine you're going to be increasing your value every time you multiply by b, right? So if you increase your x value, you're going to be multiplying by b more, right? And that will therefore increase your f of x because b is more than 1, right? So for example, if b was 2, you'd want to multiply by 2 more in order to have a higher f of x, right? Because, so if x was higher, then f of x would be higher because b is more than 1. Because basically you're multiplying by a number, like 2, you're going to double every time. And that would increase f of x. Okay, so what about decay functions? Why does it decay when b is less than 1? Well, you can imagine that if you're multiplying by something like 1/2 or -1, right? Or actually, sorry, less than 1 and greater than or equal to 0. Yeah. So you can imagine if it's like a fraction like this, if it's a fraction like this, 1/2 or 1/4. By the way, guys, I'll be getting into why I just did that with the 0 and the -1. I'll talk about that in a second, but just for now, let's just talk about decay. But let's say you have 1/2 or 1/4. The more that you multiply by b, the lower your number is going to get. So if you have an x that is high, you're going to multiply by b a lot. And that means that you're going to shrink a lot because you're halving every time, or you're quartering every time. Now, if b is more than 1, then you're going to be multiplying by something that's more than 1 a lot, and that means that you're going to increase. But if you're multiplying by something that's less than 1, you're decreasing because you're halving or you're quartering, or maybe it's like an eighth or a seventh, anything between 1 and 0, right? Okay, so what was that whole thing that I just did with the -1, right? Well, if you have a negative number as b, so where b is less than 0, what sort of situation is that? Well, let's think about it. If we have some sort of function, f, right, equals 3, or equals 1 times -1 to the x power, what would happen? Well, the first time you're definitely going to decrease, right? Because you're going 1 times -1. So you're decreasing from 1 to, so basically, let's try x equals 1, okay? F of 1 would equal 1 times -1, and that's equal to -1. What's f of 2? F of 2 is going to equal to 1 times -1 squared. What is -1 squared? Well, it's just +1, right? So that will equal +1. So when you're multiplying by a negative number like this, you're going to switch back and forth between positive and negative. And that means that it's neither a growth or a decay function, because you're first you decay, then you grow, then you decay, then you grow. It'll go -1, 1, -1. You're not decaying or growing, right? Now, if you had a negative number that was less than -1, so for example, f of x equals 1 times -2, okay, to the x, it would look something like this. At first it would be -2, and then it would be positive 4, and then it would be negative 8, and then it would be positive 16. So the magnitude of the numbers is increasing, but it's becoming negative, and then it's becoming positive, and then it's becoming negative, and then it's becoming positive. So obviously it's not a decay or a growth function, right? So just to recap, exponential functions are in the form f of x equals a times b to the x, okay, where a and b are constants and x is a variable. A represents your initial amount, b represents the amount that you're multiplying a by, and x represents how many times you're multiplying a by b, right? Okay. And we also need to remember that exponential functions can be split into two types of groups, growth and decay. And growth is where b is more than 1, right? And decay is where b is less than 1 and greater than or equal to 0. And the reason for that is because if b is more than 1, then every time you multiply by b, you're going to be increasing your value. And if it's less than 1 and greater than 0, every time you multiply by b, you're going to be decreasing your value. If b is ever less than 0, then you're going to be switching between the negative side and the positive side. So it's not really either growth or decay. That pretty much wraps up this video on exponential functions. Thank you.